Good morning. This is Unit 2, Day 11 notes. So you're going to do this for a warm-up. And then I just want to remind you of a couple of things that we learned when we were factoring. The first one was a difference of squares. Whenever we can get it into the terms a squared minus b squared, then we can factor this by a plus b times a minus b. This has to be a minus in between them. It doesn't work if it's a plus. You can't factor that. For cubics, it doesn't matter. There's one for a minus and one for the plus. When it's a minus, then it's going to be a minus b first. And then it's going to be a squared. We kind of go down 1 in degrees. So started at 3, now it's squared. Plus a times b. So this one is plus. And then plus b squared. When it's a cubed plus b cubed, then we start with a positive, a plus b. And then we're going to have a squared minus right here, ab plus b squared. There's a squared right here. I don't know, that looks weird. Okay. So we're going to look at these trigonometric functions and see when we can factor them. So cosine squared of alpha minus sine squared alpha. This is my a, and this is my b. I'm going to do exactly what I did up here. So it's going to be a plus b, so cosine of alpha plus sine of alpha times a minus b, cosine of alpha minus sine of alpha. And that's it. If we have something like this, 6 cosine squared alpha minus cosine of alpha minus 1, you can think of this as 6x squared minus x minus 1. And think about factoring that first, and then you can go back to plugging in alphas after that if you would like. So I know that the factors of 6 are 1 and 6 or 2 and 3, but if I have a 6 and I'm multiplying it by 1, I'm not going to get a difference of 1. I know that. So I know it's going to be 2 and 3, so I'm going to say 2x and 3x. My factors of 1 are 1 and 1. I know one of them has to be positive and one of them has to be negative. That does matter though, because my x's are not the same, so it might be different. I'm going to put 1 and 1. Okay, so it's 2x. I want my middle term to be negative, minus x. So my bigger one has to be negative. So I know it's going to be minus 1 and plus 1 like this. Okay, and you can FOIL this to make sure that we're right. I would always check our work. Now I'm going to plug in my cosines because this is not really the correct answer. My correct answer is 2 times cosine of alpha minus 1 times 3 cosine of alpha plus 1. So instead of x's, I just inputted the cosines. Go ahead and flip your paper over. And it says factor and look to apply common identities. We need to factor these usually. This one is sine to the 4th of x minus cosine to the 4th of x plus 1 all over 2. I'm going to factor the numerator. We can all agree that the left-hand side is more complicated than the right-hand side. So I'm going to factor the numerator of the left-hand side. And this, if this is going to be something like, I'm just going to factor these two first, because this is kind of like the difference of squares, but then I have a plus 1. So this is going to be sine squared x plus cosine squared x times sine squared x minus cosine squared x. But then I have a positive 1 up here. Remember, we can always separate the numerators of fractions, though. Now, what's really cool about this is I see the Pythagorean identity. Remember, our Pythagorean identity is sine squared theta plus cosine squared theta equals 1. I think in our first notes, I wrote this separate, or it was written differently. It was cosine squared theta plus sine squared theta equals 1, but I usually write the sine first. So this one is this right here. So I know this is 1. I'm sorry, we still have divided by 2. Maybe I'll do this. All divided by everything, divided by 2. So I know that sine squared x plus cosine squared x is 1. So I'm just going to substitute that in. 1 times sine squared x minus cosine squared x. And then I still have a plus 1 all over 2. We're trying to see if this equals the right-hand side, which is sine squared x. I can kind of get rid of these parentheses. This is just sine squared x minus cosine squared x plus 1 all over 2. But this right here is also from my Pythagorean identity. That's right here. I want 1 minus cosine of x. So what I'm going to have to do is subtract cosine squared x. And this is going to be sine squared theta equals 1 minus cosine squared theta. So I know that 1 minus cosine squared x is equal to sine squared x still plus, this is equal to sine squared x all over 2. Now, sine squared x plus sine squared x is 2 sine squared x's over 2. And 2 over 2 will cancel, and we're left with sine squared x equals the right-hand side, which is sine squared x. Got it. We did it. Alrighty, let's try this one. This is going to be kind of the same thing. So all I did is, I know I'm going to start with the left-hand side, and I rewrote the denominator because I know I'm going to have to factor it. It says create a factorable quadratic. Sorry guys, someone interrupted me. So I am going to replace the sign of x. I know that sine is equal to 1 minus cosine. So I wanted this. I'm going to replace this with 1 minus cosine. So this is 1 minus cosine. And then I still have what's left over, which is plus 2 cosine x minus 1. And then the denominator I rewrote so I could factor it. So if I pull out a negative, this is going to be cosine minus cosine minus 2, right? Everything changes sign. So this one is now positive, negative, negative. We really want our first term to be positive, though. That's why I factored out the negative sign. If you don't, that's fine. This is going to be, I'm going to rewrite the negative. I need to factor this. So I know cosine squared times cosine times cosine equals cosine squared. So I know this has to be cosine and cosine. I know that the factors of 2 are 1 and 2. It doesn't matter where I put the 1 or the 2. The positive and negative does matter. So I know it's -2, so one of them's negative. The bigger one is negative because my middle term is negative. So it's going to be -2 plus 1. Okay, now I see something that could maybe cancel. So let's rewrite the numerator. I'm just going to bring it down actually. I'm going to rewrite the numerator, which is 1 minus 1 is 0. And I have a negative cosine squared plus 2 cosine of x. I can factor out a negative from that also. Or I can factor out a negative cosine. So I'm going to factor a negative cosine. I'm going to rewrite this for you. So this is negative cosine squared x plus 2 cosine of x. So when I factor out this negative cosine of x, this is just going to be cosine of x. Oh, and then this is minus 2 now, divided by negative cosine of x plus 1 times cosine of x minus 2. I do see that these cancel, and I'm left with, so this equals 1, and I'm left with negative cosine of x over negative, don't forget this negative, parentheses, cosine of x plus 1. Now I can divide a negative divided by negative as a positive, so now I'm just going to cancel these. These are now positive. And I have cosine of x over cosine of x plus 1. And I want it to look like 1 over 1 plus secant of x. So what I'm going to do is multiply the top by 1 over cosine and the bottom by 1 over cosine. As long as you do it to the top and the bottom, that'll be okay. Cosine times 1 over cosine is 1. Cosine of x times 1 over cosine of x is 1. 1 times 1 over cosine of x is secant of x. And that does equal the right-hand side. Oh, I'm sorry. I don't want to use the arrow. I actually do not want to. That is equal to the right-hand side, which is 1 plus secant of x. 1 over 1 plus secant of x. Alrighty, we're done. They are equal. Let's try this one with a difference of cubes. So it says that this tangent cube theta plus 1 is equal to this. Well, it kind of looks like this is more complicated, but we have a formula for tangent cube theta, so it might be actually easier to manipulate this one because we have a formula for cubics. Remember, if it's a cubed, I think this one is plus, right? Plus b cubed. Then that's equal to a plus b times a squared minus ab plus b squared, right? So this is my a, and then this one is my b. So if I have this cubic, this is 1 cubed, this is 1. This is a tangent of theta plus b plus 1 times a squared, so tangent squared theta minus ab, 1 times tangent is tangent, plus tangent squared. Oh, I'm sorry, not tangent squared. This is 1 squared. B squared, which is 1 squared. Okay, but do you guys see this right here is tangent squared plus 1? This is an identity, which is secant squared. Tangent squared plus 1 is secant squared. Look at your identity sheet. So I still have tangent theta plus 1, which is actually perfect, times this is secant squared. I think they want us to write the secant squared first. So secant squared theta minus this, we still have tangent of theta. And then that looks like the right-hand side. I can't rewrite the whole right-hand side. It's not enough room. So we're done. That one was a little bit shorter, actually. I want you guys to try this one using a common denominator. So make this one a common denominator. Multiply this one by cosine over sine, and this one by 1 plus sine over 1 plus sine, and try it out. If you have any questions, let me know. Have a great day, guys.